So let me just write on this PDF document directly. Later, I will post this annotated PDF file. So you can use it, study. Yeah. At the test time, because all the course materials you can use legally, okay? Yeah, so this document in the test, you can use it, yeah. All right, so let's start. Oh, first, I need to change the color, yeah, because when I do grading, I use red one. And here, I like to use the blue color. All right. Okay, yeah. I didn't do the statistics, yeah, because it takes too much time. I just, based on my impression, yeah. For questions that most of you did well, I just skip it. I only spend my time on those questions that you have a lot of problems. Yeah. All right, the first one, yeah, easy, trivial. Yeah. But the second one, many of you missed the second one. The answer is false. Yeah. Some students select textual and numerical, but here only. I hope you pay attention to this only. Yeah. Because this statement means other than these two types of data, we cannot store other types of data in traditional database. But the fact is, we can store binary data. Store binary data directly. Not indirectly, directly, okay? All right. Remember, there is a special data type called blob, right? Big, a binary, B binary, L large object. Okay? There is a special data type, blob data type, that kind of special type we can use to store large binary. Although in our applications, we don't want to do this way, right? Think about when you store large binary data in your database, how can you view it? Nobody wants to view the binary data, right? Yes, yeah. So usually we try to use a better way to do it. Okay, yeah. We use the URL, yeah, better way. So here, or chat, let me see the chat message. May I know the timing of the all right, timing exactly the same class time. Exactly the same class time. Yeah. But some of you may not feel convenient. I understand that. You look at your schedule. This time, if some of you do not feel convenient, then you can make appointment with the test center, university test center. So yeah, because our midterm is at Wednesday, right? But not Wednesday. Yeah, I like you to choose Wednesday, the same day, different time, or Thursday, Friday, one of these 3 days. And your favorite time, you make appointment with the university test center. Okay, that's your option. That is your option. If this evening time you do not feel convenient for you, yeah, you can take that option. Okay, yeah. Otherwise, try to come to the classroom. So it's not an online test. So sit in the classroom. So I hand out, test papers, yeah, four sheets, 4 sides, yeah, because 25 questions. So I put it on 4 pages. Yeah. So you complete it in 75 minutes. Right? Our regular class time, 75 minutes. Okay, yeah. If you need a little more after that, that's okay. I allow you if you need a few more extra minutes, because after this class, I just sit here, you can use a little more time. But usually most students do not need that much time. Okay, yeah. The questions similar to our homework number 1 question and 3 quiz questions. Yeah. All right, 3 quiz questions. Yeah. All right, so any other questions, just let me know. Okay, I will explain. Yeah. All right, so here, and one student explained the argument is, even the binary data, because the form is like numerical, yeah, because you need to use the, numbers, characters, yeah. But here, when we talk about numerical data, we mean the regular numerical format, right? Regular numeric format. Okay, yeah. Not arbitrary format with numbers, because if you want to interpret using the regular numerical way, that could be different, right? Yeah. So do not try to extend that meaning. Yeah. Yeah. In that way, just, other than those 2 types, there are other different types. Multimedia data. Yeah, we talk about that. Okay, even the binary data, the type could be different, right? Image file format, video file format, they're all different. So think about that. All right, yeah. So that's this question number 2. The third one, yeah, you also quite some of you missed the third one, and some of you could be, confused by the wording here. Yeah, I understand that. Yeah, because here I talk about 2 different types of databases, one traditional, one non-traditional. Non-traditional, we refer to NoSQL, right? Yeah. All right. So the answer, for traditional, that's yes. For non-traditional, no. Okay. Yeah. For traditional, must have metadata, but for non-traditional, no, we do not need to use metadata. The structure is simple. All right. But here, or, yeah, some students talk about this, or, yeah, or that means, so here, when we consider all databases, yeah, here, all databases, all right? So this circle represents all databases, okay? Traditional, non-traditional. Okay, yeah. Traditional, non-traditional. All right, yeah. All right, so all could be here, right? Yeah. So here, my statement means so everyone in the circle has this property. All right. So if you select it at the traditional part, it's true, but when you select non-traditional part, it's false. If the statement is partially correct, not completely correct, we treat as false. Okay? Yeah. if the statement is partially correct. Okay, yeah. We just say it's false, okay? Because true means 100% correct. Okay, yeah. All right, so that's usually when we determine if a statement is correct. So we use this common way, okay? Yeah, all right. Number 4 question, is it possible that we can develop an application using a database without going through any database server? The answer is true. I talk about this case in our module 1, very early, yeah. As I remember, if not module 1, module 2, the early, pretty early time, yeah. At that time, when I talk about the database, actually there are two ways we can access database. Okay. Number 1, number 2. The first way, through database servers. Database servers. Yeah. All right. Yeah. The second way, through database engines. That's the first case. Most of the time we use the first case, but the second time we use as embedded databases. Okay. For example, some of the applications, for example, we want to install on your cell phone, okay? And that application, if you do not want it rely on network, internet, yeah, so it can still work without going through internet, okay? Yeah. It can do all the functionalities. It needs local database. It requires local database. How can you put a local database? Embedded. That's the local database. Okay. Usually the local database relatively small. Okay. Relatively small. Yeah. The whole engine is embedded. Okay. Yeah, but still very powerful. 90-something% of the queries can be implemented. Definitely not 100%. Yeah. Most commonly used queries are supported. Yeah. Pretty powerful. Okay. Yeah. Pretty powerful. Yeah. All right. For this class, I only talk about that concept. Yeah. But if it's possible, I'd like to show you a Java example using embedded database. Yeah. Yeah. Java has several different embedded databases. Yeah. MySQL does not have the embedded version, yeah, but there are several other. One I mentioned in class, it's called a Derby. Derby, okay, yeah. So now it is an open source project. Yeah. All right. Many of you probably forgot that background, yeah, because you didn't see the example, so you may not be able to, recall that special case. Okay, all right. Number 5, yeah, some students got confused, yeah, because some students wrote some comments. Yeah, here, let me explain a little bit. In class, we spend a lot of time on this question. Data normalization should always be implemented to avoid any redundancy to save storage space. Yeah, answer is false. Because performance is more important. All right, yeah. So here you can save storage space, but better performance yep. Is more important than saving space, right? Space, yeah. People can add more space. The cost not too high, yeah. And but if you can get a better performance, that's worth it. Okay, yeah. So when you have the trade-off between space and the performance, usually people favor the performance side. Okay, more important. Yeah. All right, so that's this question. Yeah, because next few questions we talk about performance, right? Number 6, main reason, control. Yeah. So if you combine question 5 and 6, you can see the relationship. Yeah. Because question 6, you select improve performance. Yeah. But you need to make connection. Yeah. It's a trade-off issue. Save storage space, improve performance. That's a trade-off issue. Okay. Yeah. All right. Okay. Number 7. Yeah, a few students missed this one. Let me explain a little bit. Answer database definition. Yeah. One student select C, primary data of databases. Do not get confused here, because database definition we treat as the secondary data. Primary data, we mean the business data. The business data directly. Database definition, secondary data, the data is used to provide services for the business data. Okay, that's the secondary. Yeah. You use that part of the data to help you manage your business data, the primary data. All right, yeah. But stored procedure belongs to the database definition part. Yeah. So last time I explained how do we write stored procedures. That's basically SQL functions. We write the definitions as the SQL functions. Okay. When we run the SQL statements, yeah, so we use SQL statements to write the store procedure. When we run those statements in our SQL window, then this part goes to the database definition part. Okay, yeah, because later when you want to export your database, export the schema part. Schema. The schema part will contain this definition. All the definitions of the stored procedures will be included in the exported schema. Okay. Yeah. Yeah. All right. So that's this question, number 7. Yeah. Next one, question number 8. When we compare, so this question, many of you missed this one. Yeah. Compare 2 strings with all characters in digits. Yeah, even we consider in digits. Okay, but we treat as characters, strings. The more digits a string has, the larger the value of the string. It's false, but quite some students select true. Yeah. Think about when we compare, here we compare strings. We compare strings. Okay, it's different from number comparison. Okay. The reason is number comparisons using numeric order. Right? But string using alphabetic order. That's quite different, right? Alphabetic order, also called a dictionary order. Quite different. Let me give you a simple example here. Yeah, I remember in class, I did one example. Yeah, for example, look at this string 1, 2, 3, 3 digits string. Yeah. And another string, fewer number of digits, 2, 4, for example. Yeah. But if you compare numerically 123 and 24, so definitely 123 is greater than 24. But when you compare string alphabetic order, the first digit is 1 smaller than the first digit of the second string 2, because we use the dictionary order, right? You compare the first character first. Based on the first character, we can already say the first string is less than the second string. Then you do not need to look at the remaining characters. Okay, the first character can already determine the order. Only when the first character are the same, then you compare the second character and so on. Dictionary order, alphabetic order, numeric, it's different. Okay, so that's the essence of this question. Yeah. All right. Number 9, most of you did well. I remember only one student missed this one. Yeah, SQL. Yeah, programming language. Yeah, store procedure. Yeah, we use completely SQL statements. Yeah. All right. Number 10. Yes, you missed quite a lot. Number 10. Yeah. If a SQL table can be stored based on a particular column. All right, so here we'll talk about one column. Then we can be sorted. Yeah. All right, so here sorted. Okay, sorted means there is an order, right? There is an order available for this column. Okay. Then we can say that this column must correspond to a key of the table. Key of the table the requirement is unique values, right? Then we can say it's a key field, unique value. But a column whose values can be sorted, not necessarily unique, right? Yeah. Yeah. Its values are not necessarily unique. Okay, yeah. That means it may contain duplicate values, but you can still sort the rows based on the values of this column. Okay, no problem. Yeah. So that's the reason it is false. Okay, yeah. All right. So here, consider the case duplicate. Duplicate values. Okay, yeah. Duplicate values, but ordered. Okay, yeah. All right. Number 11. Yeah, true. Yeah. Reference the table itself. Yeah. Remember, we use the alter statement. Alter, right? Alter table statement. Okay, so we can do this. All right. Number 12, if, yeah, so many of you missed this one because you may not pay attention to a special case. Yeah. Composite key case. Yeah. Here, I designed this question to check your understanding on the composite key concept. If we can define a key, so here we do not say what kind of key it is, right? No. It could be single column key or composite key. No. Then we can say that there exists a column in the table that has unique values. No. So here, yeah. Remember, I used the example last time, you know, course table in the university database. Okay, that example. In that one, consider course number. That column, that table has only two columns. One course number column, second session number column. Okay, yeah. None of them has unique values. Yeah, course numbers could be repeated multiple times, session number repeated multiple times. But when you combine them as a composite key, as a tuple, yeah, as a tuple values, you will consider tuple values, right? Then it's unique. Okay, and it can be used as a key. Okay, we may have situation like this. Okay, yeah. No unique single column values, but in that situation, we can consider the composite keys. Yeah. That would give us more control on the table, more control. Okay. Otherwise, it's hard to identify individual rows. Now you have composite keys. You can use any of the composite keys to identify individual rows. Okay. Yeah. All right. So that's the question number 12. Yeah. Number 13, easy. Number 14. Yeah. Right. So here the employee example. Yeah. Use our employee example. Employee table. Okay. In the company database. Okay. Yeah. There we use E copy and S copy, supervisor, employee. Yeah. So you can see, yeah, we have that. Number 15 can be joined with appropriate. Oh, yeah. So here, right? Because in that case, if you do not use aliases, you cannot identify, you know, different fields. Okay. Yeah. But here, that example can also be used, right? Table with itself, that employee table, you know, with itself, that example can also be used. Yeah. All right. Number 16, yeah. Most of you got this one. A small number of students missed this one. Yeah. Because when you use the equal sign, that operator to do comparison, you do not require an order because you compare character by character, bit by bit. You do not need any order definition, right? When you need an order, you need to see which one is greater, which one is smaller. But here we don't need to get greater than, smaller than information. We only want to see two pieces of data are exactly the same or not. Yeah, so from that point of view, no order needed. Yeah. All right, so then that's the reason behind the hashing technique. Okay. While we can apply hashing technique, we can compare equal or not. Okay. We can two given keys given. No order is needed. We don't need order. Then we just define our hash function to map the given key to different value, to shorter different values. Then with that, then we can find a location for the entry, for the given data entry. Okay, yeah, that's enough. We don't need which one is greater, which one is smaller, because we do not need to solve it. We only need to find a location in our hash table, and then later we can find that entry, data entry, by the same key. By the same key, we can find it, retrieve it. That's enough. So that is that special case. Order is not needed. Okay, all right. Number 17, yeah, most of you got this one. Yeah, small number of students missed this one. The reason is this explicitly. You don't need declare this not null explicitly for the primary key, because by default, it is primary key values cannot be null by default, right? Yeah. But if you declare not null, no problem. Yeah, but just redundant, not necessary. Okay. Yeah. All right. Then number 8. Yeah, most of you missed this one. Yeah. Here, let me explain clearly. So why I calculate this. Yeah. First, you need to understand the projection, and the second, order of attributes. These two concepts, if you understand well, you can do the calculation correctly. Yeah, let me explain here. 3 columns. Yeah, let me use the notation C1, C2, and C3. Okay, all right. When we do projection, so we want to consider all possible different projections we can have using some of the 3 columns. All right. Yeah. The first type, single attribute projection. Okay, single attribute projection. Okay, all right. C1, C2, C3. Okay, yeah. So we have 3 different projections. Yeah, that's easy. Yeah, this case, easy. All right. Second, 2 attribute projection, but order matters. Remember, the order matters. All right. So let me C1, C2, and a C2, C1, we treat as different projection. How about that? C2, C1, that's different projection, right? C1, C3, and a C3, C1, we treat as different projection. Okay, yeah. And C2, C3, and a C3, C2 as different projects. So total we have 6. Okay, yeah. Number 3, 3 column projection, C1, C2, C3, C1, C3, C2, right? Yeah. The first one is C2, C2, C1, C3, C2, C3, C1, all right? Then the last one, first column is C3, C1, C2, C3, C2, C1, okay? All right, if you want to list all of them, another 6, okay? So 3 plus 6 plus 6, 15. If you want to list all of them, you can do this. But if you, because you can do the counting, right? You can do calculation. Okay, yeah. And we know, yeah, because the order matters, right? The order matters, yeah. Right, so when you do the, all right, do the calculation now. Yeah, the calculation. This is 3 times 2. Yeah, because the first position, yeah, here we use the basic counting technique. The first position, there are 3 choices. The second position, you need to exclude the first choice the remaining two choices. So you put 2. Okay, so that's 2. Now you look at the third case, 3 factorial, right? Yeah, 3 factorial. Yeah. First one, 3 choices. Second one, 2 choices. Third one, 1 choice. 3 factorial, also 2. Also 6. Yeah. All right. Yeah. Try to understand this kind of structure. Okay, the order matters. Yeah. Some of you, when I saw your answers, you didn't factor in the order difference. So that I'll give you a partial credit. Okay. I look at your answers. Yeah. So because some students put 3 plus 3 plus 1, 7, for example, right? Yeah. 3. So the case number 1, yeah, 3, no problem. This one easy. But case number 2, they do not consider switching order of each pair, only 3 cases. The third one, C1, C2, C3, they do not consider the, different permutations. So they just treat as 1. So the total 3 plus 3 plus 1, 7. Yeah, I give partial credit. Yeah, 2 points, partial credit. Okay. Yeah. All right. Remaining, yeah. Number 19, easy. Number 20, also easy. Number 21, also easy, because all of you got correct answer. All of you. Okay. Yeah. Yeah. But here, I like you to know why you get the correct answer. All right. Yeah. Because in the test, I will give you a different Boolean expression. Yeah. I hope you can find the answer correctly. Yeah. In the midterm. Yeah. First, let's evaluate the first parenthesis, the Boolean value. True or unknown. True. We know the first operand is true, then no matter what is the value of the second operator, it is true, right? Yeah. True, because true or false also true. Okay. True or true must be true. All right. So the first parenthesis, true. The second parenthesis, false and unknown. There is a false operand. When you use false to do an operation with any value, Boolean value, it is false. Okay. So we can simplify first parenthesis, second parenthesis as one single Boolean value. Yeah, false here. All right. Yeah. Now, true and false, right? That's false. Okay. Yeah. So these two together, true and false. So we simplify it as false. Okay. The last one, false or not unknown. Not unknown, we know the same as unknown, right? Not unknown. Yeah. Not unknown. Yeah. Okay. Still the same as unknown. Okay. False or unknown, still all, right? This time is not and, right? It's all, okay? Yeah. The or operator important. That means sometimes true, sometimes false. So your false with true, that's true. False or false, that's false. So that means it is unknown. Okay? It cannot be determined. True or false, it cannot be determined. Yeah. So I hope you follow this kind of analysis to find the value. Okay. Yeah. So I will give you a different expression, Yeah. But you can do step by step, like this one. Okay. Yeah. All right. Number 22, easy. Number 23 also easy. 24 also easy. Yeah. The last one, similar to question number 17. Yeah. But here we need to do slightly different. Yeah. Assume that a SQL table with 4 columns. The first column is the primary key. Okay. Yeah. And the remaining 3 columns are non-key fields. Okay. Yeah. All right. Yeah. So this condition we need to consider. If we want to construct a composite secondary key, yeah, here secondary, not primary. So we exclude the primary key. Okay, secondary key. Yeah, from the 3 non-key fields. How many different possible secondary keys we can have? Yeah, similar to our discussion in question number 17, but we exclude single column case. Yeah. So so we do not repeat from question number 17. But excluding the single column case. Yeah. Single column case because we know they are non-key fields. Non-key. Oh, and yeah, we know non-key field. Another thing is because we need a composite secondary key, right? Single column cannot be composite key, right? So at least two column and yeah. So for the 2 column case, okay, yeah, and 3 columns composite key with order, yeah. Info, okay. Yeah. In that way, you know, you can find this answer 12. Okay, yeah. Yeah. All right. Yeah. These 2 questions you missed the most. Yeah. So some of students just got a partial credit, yeah, but not perfect. Yeah. Nobody got perfect answers for these 2 questions. Yeah. Yeah. But after you understand the answers here, I hope in the midterm exam, I will give you at least 1 such question. Yeah. 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 1 should be enough, yeah, because we have many different question types to test. Yeah, because I need to give you a few query questions. After your homework assignment number 2, you need to do a few query questions. So we do not have much room, you know, for the same concept. I don't want to create 2 questions for the same concept, right? Yeah, 1 question is enough. Here, this one composite key concept. Yeah. So 1 question is enough. Yeah. All right. Here, yeah, I complete question review, question discussion for homework assignment number 1. Yeah. Although I have a little more than 10 minutes, yeah, but I feel it may not be a good way to talk about the slides we left in the part A of module 5. Yeah. Yeah. Although we can do a few slides, yeah, but you know, our main focus right now is on the midterm, right? So I may like you focus on the midterm. Yeah. Yeah. For the, you know, material module 5. Yeah. let me tell you this way. All right. Yeah. Midterm. All right. Midterm coverage. Okay. Midterm coverage. Okay. Module 1 through 4. Okay. Yeah. You do not need to study module 5 for your midterm test. Although in these 2 weeks, when I have time, I will keep going. In module 5, keep going, because we cannot waste time. But you do not need to prepare module 1 through, prepare module 5 for your midterm. Okay, yeah. Leave the module 5 to final exam. Okay, module 5, module 6, we will put in final exam. All right, yeah.